Grant, why don't you tell us a little bit about you and your team and what your team actually does?
Sure. I'm really excited to be here today. Thanks for having me, Ruse. My name's Grant Jenks. I'm a senior staff software engineer here at LinkedIn. That makes me the technical lead for Developer Insights, which is part of the developer productivity organization here. We try and make the developer experience as best it can be here at LinkedIn. So I'm really excited about that. This team's existed for about 2 years, although our work in developer productivity goes back a lot longer than that.
And tell us a bit. There's all these organizations that do productivity engineering well. I mean, there's not many. I mean, I would say not everybody's doing an amazing job. It's a pioneering thing. It's a new thing. But tell us about your productivity engineer organization at LinkedIn, right? And I kind of want to stress the point here that, hey, Rome wasn't built in a day kind of a thing, and you need a whole team and whatnot behind it. So tell us a little bit more about that.
Yeah, so the productivity engineering org is hundreds of engineers and managers and program managers and people working kind of horizontally to support the company. I'll tell you a little bit about some of the sibling teams in our org. We have a fairly large group called Development Experience, sometimes referred to as DevX. They're responsible for providing the developer with the right tools and the right experience at the right time. I'm part of a team called Engagement and Insights. So we think of engagement as kind of the qualitative side of engaging with developers, and insights kind of the quantitative side, like how do we measure developer workflows and how do we make meaningful changes there. Delivery tools is kind of the development infra team. They keep everything running from code reviews and the CI infrastructure and everything it takes to deliver a great experience. And then client application frameworks is a team that focuses on web and UI frameworks. It focuses on mobile infrastructure, everything from SDKs for doing crash reporting to accessibility tools and widgets, and trying to provide the set of guidelines to do great developer, great products really, and support developers in doing so.
Great. And you mentioned hundreds, right? And that's what it takes. Folks that are doing this well, right, on a large scale. You need teams of folks responsible for different things and whatnot. And of course, being in developer insights, I mean, we know here at Gradle, in the Gradle world, right, that to do productivity engineering, you need to start with collecting data, right? You need tools and whatnot behind that. Tell us a bit about, what kind of data are you guys collecting and what tools you use?
Yeah, so if we think about the scale of LinkedIn engineering, if you could go back just one slide real quick. If we think about the scale of LinkedIn engineering, right, we have thousands of engineers around the world. We have teams in the Bay Area. We have teams on the East Coast, all across America. We have teams in India. We have teams in the European Union, all around the world, right? And so all these engineers are trying to collaborate. They're trying to develop across like tens of thousands of repositories. They're doing tens of millions of builds, lots of CI jobs. We're looking at over 100 million lines of code. We're doing hundreds of thousands of merges per quarter. We're producing hundreds of millions of artifacts and doing millions of deployments. This kind of scale quickly goes beyond, what you can manage in an Excel spreadsheet. And if you start to think about what are all the different sources of inputs to this world? How are we able to track all of that? I start to kind of think of it as like a huge data ingestion task. And so when we talk about data ingestion, if you want to go to slide 5 now, we have different sources, right? We have these front-end web applications that we've built for doing, say, deployments or for importing external libraries. We have back-end services. that decide, what versions of software can be deployed and which versions of software can be consumed. We have lots of CLI tools that we've built and that we've integrated into the LinkedIn ecosystem. All of these are producing different data sets. We're consuming things from GitHub, we're consuming Gradle build scans, we're tracking internal CLI indications, we're kind of ETLing all of these backends, and all of that means we have Kafka and MySQL databases and Azure App Analytics, and they all kind of feed through this pipeline called Goblin. And Goblin is kind of the way that we ingest everything. And once we've ingested everything, it lands in what we call the grid. So if you look at the data processing kind of diagram here, we have kind of in LinkedIn's own internal data lake. Part of that is Hadoop backed. We have Hive databases. We have Pinot databases. Some of these you can just Google in terms of the LinkedIn engineering blog if people want to learn more about Pinot. But we have basically this huge data lake infrastructure. We have a set of tools for doing data governance in terms of Nuage, Data Hub, Dolly. These are different ways to ensure developer privacy, ways to meet security requirements. And then we have a bunch of tools for processing data, everything from notebooks that let you do, really kind of exploratory data analysis to Trino that lets you do huge queries at scale, to Azkaban and UMP that allow us to productionize kind of these data pipelines. So one of the things that's been exciting for us actually as part of developer productivity at LinkedIn, I think LinkedIn is well known for doing lots of analytics and for tracking, and building a great web experience. And we don't really operate at the scale, right, of LinkedIn.com, right? They're processing petabytes of data. We're processing terabytes of data. But we get to use the same technologies and the same platforms. And so it's really exciting to see not only some of these platforms scale up, but to also see some of them scale down so that we can take advantage of them. After we do all that data processing, we actually will, we have to present it to people. That's where our real impact comes in. We do that through in-house kind of visualization tools. There's one called Retina. We use some of the standard Power BI and Tableau type dashboarding tools. We use some ad hoc queries, and we can even send data out to external services through something called GAP. For that middle one, the insight services, that's actually where I'm most excited. We have a couple of internal services, one of them called Insights Hub, where we've kind of started to aggregate all of the metrics together to create a developer portal. And then also we have something called Insights Labs that allows us to experiment, join different data sets, answer the hundreds of questions that come up every quarter around, hey, can you look at this? Can you measure that? Have we ever tried this experiment? And so it's really fun to be able to put those things together and then publish them in a quick dashboard.
Yeah, that's awesome. I mean, super complex, right?
Yeah.
It's great to, in the past, you always just living in the Bay Area, you hear, LinkedIn has some of the best data scientists, are available in the market, right? And it's great for you guys to kind of take advantage of that and tap into some of those tools. And so so you got the tools and you have the data and you're able to make sense and organize this data to make it actionable. So what are some of the biggest productivity engineering wins and findings and lessons learned that you can share with us here today? Yeah,
I mean, think about, we think a lot about like, what do we make, right, at the end of the day? Because as a developer insights team and as developer productivity, developers are actually pretty thoughtful already, right? Like we don't typically waste our time if we don't have to. And so engaging with developers means, creating the right kinds of tools and the right kinds of ways. And one of the things that I'd like to share is kind of what we call the weather analogy. If you think about like a factory that, let's say, produces umbrellas, and this factory is like enormously successful. So they're just churning out umbrellas. And some people are using the umbrellas like for rain. Obviously, that's an important use case for umbrellas. But other people are using the umbrellas, say, for like shade, right? Like that's another important use case for umbrellas. sometimes you don't understand how the things you're producing are getting used. And so in that process, you need to create different kinds of what I'll call meters. Like you need thermometers to know, like, well, what's the temperature out? If it's 100 degrees out and people are all using your umbrellas, it's probably not for rain. And you need to make barometers and altimeters. Like if somebody's using your umbrella at really high altitudes, maybe they actually need a parachute and they're not using your umbrella the way you anticipated. So we kind of think of our team and our role within developer productivity as trying to understand that landscape and then trying to, move more toward what people really need at the right time in the right way. So, for us, I think one of our biggest kind of wins was around last year. We hit the COVID-19 pandemic and we were suddenly forced all to like shelter in place. And I think there was kind of this collective, held breath moment where people wondered, like, is the world going to halt? Like, are we all stopped? And certainly there was a lot of senior leadership here at LinkedIn that was wondering, like, how is everyone doing? Are we still shipping software? What's getting done? And so we were thinking a lot about, could you go back one slide, Justin? We were thinking a lot about like, hey, when are people working? And how do we measure things like collaboration? Are people still able to like work together if we're all sheltered in place? We were thinking a lot about like builds. Like if you're building at home and you're on your dial-up connection, is that still a fast build? And we saw a whole bunch of trends in that space. So I would say, during the first couple, 2 to 4 months of the shelter in place orders, we were looking a lot at code review activity, trying to understand when is it happening and is it happening less or more? Do developers feel satisfied with it? And we were a little, surprised by the results. So here's a chart that shows kind of code review activity throughout the day. And we've bucketed it into kind of different groups of hours. And you can see like there's a lot more activity happening during commute hours, during lunch hours, during evening hours. And if we even looked at the relative comparison, there's a lot more happening during sleep hours. And this was something that was kind of a good news, bad news, because what we want to see is we want to see the metrics go up and to the right. That's always the ideal. And it looked at first glance like, hey, there's more activity. Isn't that good? Like, shouldn't we get excited? But then we also had feedback data and survey data where employees and developers are telling us like, yeah, it's hard. Like, I'm not sure. Everybody probably remembers those news articles, right? About, I'm not sure what day it is anymore. Is it Sunday? Is it Saturday? Is it Monday? Is it night? Is it morning? Everything's blurred together, right? Because we were all with our families and stuck kind of at home. And so, that gave us a very unique picture of, and I think probably a crisper picture of like, here's how people are really doing. People are forced to use these tools and these technologies because they can't turn to their coworker in the office. People are, not maybe doing great, but we see increased usage of certain platforms and tools. Like if your at-home network bandwidth isn't great and your laptop isn't as fast as you want to use the data center. So we saw like more testing in CI. We saw contention for those data center resources go up. We saw download speeds when doing a build. Those were not great when everybody's at home. You kind of get what we call the weekend speeds because people aren't in the office. And this actually drove a whole bunch of initiatives and kind of realigned some of our priorities to say, hey, if that's going to be our future, this is a great chart too. This shows, from Gradle enterprise build scans, what was our download speed like? And you can kind of see that dark line here is when we shifted and we had to shelter in place. We got what we call like the weekend build speeds. This is when people, they're relying on their, at-home network bandwidth. And if you have to do a lot of downloads or uploads as part of your build, this is a killer to productivity. So it really caused us to kind of change some of our priorities, introduce some new initiatives, deploy some some kind of hot fixes. And I think it was a huge impact on the company as a whole.
And one question we get a lot, and I know we didn't have this on our list of questions, so sorry if it sounds like a curveball to you, Grant. But we get this all the time, like, hey, work from home during the pandemic, did it make developers more productive or less productive? Right? With the data that you all have seen, what did you make of that?
It's really it's a complex landscape because, like I said, some metrics suddenly went up and to the right, and we thought, oh my gosh, we see more activity. Is that good? And some metrics went down, right? Where like we're looking at average download speeds, and we go, oh, that's not good. And then you complement that with qualitative sources, and you say like, well, let's just ask people, how are they doing? And there was tons of feedback that came through, oh, I need this tool to do this faster, or not do this, or stop checking that, or I wish I could build disconnected from this. And so it really caused a lot of teams to think about, okay, this is going to change our schedule. This is going to change our priorities. So I don't have like a single answer that would say, oh yeah, I can't say everybody was more productive. I can't say everybody was less productive. I can say that it really changed how we prioritized certain initiatives. And for the most part, we're now at a point where we're past work from home. We're in a period that we call hybrid work. And it's actually just as complex as work from home was. You have now teams where half the team is going into the office every week, half the team is staying home. You have teams where you're more geographically distributed than you were before. Some people have moved, and that creates a new set of requirements around, hey, how do we do collaboration from design to implementation to deployment?
So here's my takeaway from this is that things are constantly changing in software development as a whole. And the pandemic kind of accelerated some of that. And especially, when you go outside of the tech world with the whole, Justin and I talk about this all the time, the whole digitalization kind of factor of more companies going, towards software and having to become digital to survive, right? So this thing is constantly changing, and you need the right tools to find these changes and adapt and reprioritize. And you need to do that with the tools and data that you either got to, you got to build these things, and you need teams to kind of work on them. And so there's no clear answer for everything, because this is, things are constantly, changing, as you mentioned, right?
Developer productivity, in my experience, has always been kind of like a meta team, right? Like, here's a team that's thinking about how we do things and trying to make them better. And there's a saying we like to use a lot. I think I have a slide for it where, we say a little bit of slope makes up for a lot of y-intercept. And the idea here is that everybody's starting at different places. And productivity engineering especially is really about trying to change just that angle, just the slope of that line, because over time, that's the thing that comes to dominate the quality of engineering orgs and the amount that they can produce and the quality of products and the value to end users, and especially to LinkedIn members. So in that regard, developer productivity is a meta team. I would say that developer insights is like a meta team, right? Like, here's a team that is trying to look at productivity and trying to work with all these partner teams to say, hey, is that working as well as you had hoped? How can we help you make that even better? How can we get you, the right person to talk to learn about what features are necessary? And I think one of the big things that came out of that, kind of COVID-19 pandemic, and one of the things I saw that I was really impressed by was how, it became a really significant part of senior leadership's kind of mindset to think, how do we care for developers? How do we do our best to care for everyone working here at LinkedIn? And that doesn't just mean making them more productive, right? Like, that's a really important part of it, but that's not everything. And I think that becomes, for a lot of companies, that becomes kind of a distinguishing characteristic. Do they really care about me? right? You hear that quite a bit. And we actually have a saying at LinkedIn, like people don't leave companies, they leave managers. And a lot of people talk about, does my manager really care about me? And it's been really interesting and powerful, I think, to see how, senior leadership at LinkedIn and across the company has really wanted to not just know, is everything up and to the right, but know, hey, are our systems the right ones? Like, are people excited to be here? Are you excited to come into the office today? So that's had a really big impact on our work overall.
So we've got two questions that are actually very tactical. So I think they're going to be pretty straightforward to answer. So let's kind of go for it. First is a question. Matthew is asking, question for Gradle build download speed. How did you get this metric out of Gradle Enterprise? Did you use the export API or something else to pull it out?
And I want to double click on that as well. You should maybe, Grant, just take a moment to explain what specifically download speed you're referring to. Is it, dependency downloads, or is it build caching or whatnot?
Yeah, so in this case, I think it's actually all of the above. We're aggregating, again, across about 10 million builds, and we're looking at a variety of different products. Some of those are web backends. Some of those are stateful systems. There's CLIs in there. There's a huge variety of things. For us, as I described kind of at the beginning, for our data ingestion layer, we have a service that actually interacts with the Gradle Enterprise and receives the build scans. And then from those build scans, it actually creates a series of Kafka events, which is what's worked really well for our team. So we kind of grab those Kafka events and then ETL them into our grid. And that's where we can do all of our data processing. So I think by default, our build scans, they last maybe a month or so. But once we ETL them through Kafka into the grid, we actually keep them for as long as possible, almost indefinite.
And I can help answer the other part. I'm pretty sure it's through the Gradle Enterprise Export API as we, help kind of work with you guys to get that data out.
Yeah, I think so. I think it's a web service that's calling that API and then generating Kafka events.
No, and LinkedIn invented Kafka, so that makes a lot of sense.
We use it a lot.
Just sitting next to in the panel in the show here earlier today, literally sitting next to one of Confluent folks who broke out of LinkedIn and helped develop Kafka. Anyway, next question then from Eric. Do you also measure code review rejects? So do you also measure, when a code review is rejected? Yeah,
so the term that we would use is not rejects, but we have this notion of a discarded change or a closed PR. We do track that over time, trying to understand, like, hey, are these piling up? For the most part, we haven't seen that. I don't think we've seen meaningful changes in that over time. So it hasn't been as much a focus for us. But it's certainly part of the metrics and all the raw data that we collect.
Jared is asking, it sounds like your DPE organization serves back-end, front-end, and mobile developers all at the same time. How do you reconcile differences in tool set, language, workflow, et cetera, across these different domains? It's a great question.
That's a great question. And I think this is, really getting at, hey, there's such a diversity out there. The tools that you use to build an iOS application are very different than the tools that you build for a web scale backend service, and very different from a stateful system like a database. How do you support all of that? And it's interesting. I think LinkedIn has a really unique culture in this regard because we have kind of a common foundational layer. Everyone at LinkedIn is using pretty much the same code review platform, the same source control system, the same CI system, the same deployment system. And we've had to go and engineer those different systems to support a really wide variety of development patterns and development teams. We do have specialized teams, like there is a part of the build platforms team that focuses on how do we make iOS builds as fast as possible. And sometimes what that means is we have to invest in more than one technology. We use Gradle for a lot of our builds. We're using Ember a lot in our web builds. We're using Bazel for some of our builds. And so we kind of have a heterogeneous environment in some ways where we make investments in different platforms to do what's best for those teams, to make them as productive as possible. And we've tried to, I think, kind of avoid, trying to fit a round, what's the saying, like a round peg in a square hole, or a square peg in a round hole, where, sometimes you have orgs that try and think, we're only going to bet on one. We're going to do everything through this one tool. And I think that there are some common standards that we've been able to bet on, and there are some common interfaces that we've been able to define for the company. But for the most part, letting developers use what is kind of native to them and what's part of their experience has worked out better for us than trying to create, one tool to rule them all. So it's through a variety of multiple teams and organizations that specialize in those different domains. It's through a variety of standard interfaces that we kind of all accept at LinkedIn. And then it's also through the native tooling that works best for those different platforms.
And it's interesting, not all companies have the support that you all have to collect data from all these different places and put it in a centralized place and be able to make sense out of it, right? I mean, it's a huge challenge, right? Not all software organizations have that luxury. So you see a lot of this standardization on tools just for collecting metrics and whatnot. I mean, we've seen folks wrapping Gradle around JavaScript builds just to capture some data there. But
related
it's a hard
that,
problem.
Trying to define, what is a build has actually been a big challenge for us as part of the developer insights team, because, when we talk to a web developer who's doing front end work, they expect to be able to save a file, switch over to their browser and hit refresh and have it show up almost instantaneously. Like they are measuring their build in terms of seconds. And when we talk to an iOS engineer, they expect to, make some changes, write some tests, get those tests working, and then send it to a simulator or send it to a device. They're measuring all of that on the span of minutes. And so trying to, paint a picture of here's how everybody is experiencing build becomes really challenging, because when you're at, if you're one of those executives or someone who wants the 10,000 foot view, you probably only have time for one or two charts, one or two metrics. And so you get a question like, well, how is build performance? Do I need to invest in it? And you have to really be able to distill it down into something, very quickly digestible and meaningful in order to have that impact on priorities and, initiatives across the company.
Yeah, that's a good point. And Justin, there's a really quick one in there from Alexander. I think Grant could probably knock that one out in a few seconds.
Yeah, there's a few of these. I don't want to, and I think we'll have time for more Q&A too at the end of this thing. But yeah, this one is a super easy one too. What's the product engineer to dev success or productivity engineer ratio in LinkedIn? In other words, how many productivity engineers do you have? How many developers do you have?
Headcount wise?
Yeah.
Yeah. So I have to paint with a pretty broad stroke here, but there are thousands of engineers at LinkedIn. I would say there are hundreds of us working on developer productivity. So take that for what you will. It's somewhere between 10 to 1 and 100 to 1, depending on how you want to measure those things. And I will also say, like, developer productivity, the org that I'm immediately part of has plenty of complementary teams. Some of those teams are focused on specific products. There is something that we call flagship productivity. They focus on the flagship product. There is kind of the more general productivity engineering that focuses on things, like we obviously have IT and support here at LinkedIn, and we need to provision people with hardware and stuff. We don't focus on that as much as part of developer productivity, but we have to work across all those different organizations. So, again, with a broad stroke, thousands of engineers at LinkedIn, hundreds in developer productivity.
Yeah, one last little bit of detail there, though, to answer that ratio question, because we had that same question come up in the Netflix Lowdown a couple of months ago, and their ratio was 12 to 1. So it's kind of interesting. We hear the order of magnitude, like thousands to tens of thousands. So that 1 to 12 is around that order of magnitude range too. Yeah. So I think that's a good data point. Yeah.
Yep.
Anyway.
So we talked about builds. We talked about build speed. We talked about the data. One thing that we get a lot of recently is flaky tests. And it's a problem that everyone has. No one has the perfect solution to it. How are you guys measuring that? And what would you say is the impact of flaky tests on your pipelines and your software engineering process in general?
Yeah, when you think about test flakiness, it really impacts the whole development process, right? Because you're in your IDE, you're executing tests, you're doing code reviews, and as part of that process, CI is executing tests. You have post-merge testing that does integration testing. And so any flakiness in that whole process is going to be a pain for developers. And some of that flakiness, comes from the reliability of the systems that we manage. Some of that flakiness comes from the code that developers have written or that's part of the product. And some of it is the interaction of the two. So we actually have 3 different, kind of metrics or initiatives. We look at something called merge success rate. So when you finally pass code review and you've done all your development, we've merged it into, main, and we're now going to prepare it so that it could be deployed. What's the success rate of that final gauntlet of testing? This usually involves integration testing. And that's a combination actually of both the reliability of our systems and the flakiness of your code. We also measure, as best we can, what we just call CI reliability. Like how often does the pipeline fail or does testing fail because maybe, something in staging isn't working correctly or something internally isn't working correctly, like we're having a major outage or some kind of internal issue. And then the third way that we think about it is what we call CI flakiness. Like we will rerun a known good version and try and figure out, hey, how often does this known good fail? And that's kind of a signal for us about, hey, if the CI reliability and everything does its job, there's still some concern if this CI flakiness isn't 100% or the reliability of your test isn't 100%. And then the intersection of those two becomes merge success rate. So that's mostly how we think about test flakiness in the CI pipeline so far. There have been, we do have like a test experience team that tries to, look at individual tests and creates all these fantastic dashboards and analysis, and has even tried to look at, hey, you need to disable this test, or this test is flipping and flopping back and forth. We even have tools that will try and protect head, like we call those the guardian, that will go and say, hey, this test is failing and we need to keep head green, disable the test, like keep moving forward. As I said, like we have this huge ecosystem of development. On this slide, you'll see we have 10,000 repositories. Some of those repositories do hundreds to thousands of check-ins per day. Some of those repositories will do 1 check-in per year. So we've really had to design our systems to scale LinkedIn's development to handle that wide variety of use cases. And that's kind of how we address some of the flakiness that we see in the CI pipeline.
And for us, like when we do a lot of talking to these developers and the application teams, and one of the things that most folks complain about is build time. Where would you, and it's a hard thing, I know it's a hard thing to kind of say, but just from the data that you've seen, your opinion, what do you think is the most destructive in productivity of engineers? Build times, flaky tests, reliability, time spent on debugging or blocked on whatever that's getting them out of their creative flow. Where would you, what's your opinion on that? I know it's a little off script, but just curious.
No, we have a set of metrics and we've done some design around what we call end-to-end metrics. So tracking all the way from, the first commit that you did on a new branch to you created a PR and you shared it with other people, maybe in a draft state. You started getting some feedback on that PR. You now took the PR out of draft state. Maybe there's a design doc that now supports it. People are rallying behind this feature, this fix, whatever it is. It's getting whatever approvals it needs to. It's getting tested. It's getting iterated on. It now goes through CI because it's been merged, and now it's ready for deployment, and then it goes out and gets deployed, right? So all of those different phases have success rates that we track. We track build success rate. We track CI success rate, deployment success rate. And we kind of look at all of those and then say, like, hey, where are the bottlenecks? And I was really surprised actually to learn one of the bottlenecks that kind of popped up. And I don't know if it's the most important, but there's a process by which, the way we make software scale is by refactoring it into libraries that can be consumed and deployed. And so in that process of creating a library, we now actually can answer the question, well, how long, when you publish a new version of your library, how long does it take for that to get consumed by products that then get deployed? What's that period like? And it's surprising that that's actually one of the biggest gaps or one of the biggest bottlenecks in the process. And so we have initiatives underway right now in order to try and shorten that as much as possible, so that people can still kind of operate asynchronously. Because if I'm developing a stateful system, upgrading everyone at the same time, keeping everybody at the same level can be extremely difficult. So, being able to make a breaking change and bump a major version is a huge feature that we support. But it also means that now people need to upgrade to that new major version. And we have a whole ecosystem of dependency engineering that makes sure that we get all of that tested correctly. And we know which systems, are going to break on which changes, and we know which versions need to be bumped at what time, so that, the whole pipeline from, again, review to deploy can be as fast as possible. So it turns out actually consuming dependencies is one of those challenging parts for us.
Very interesting. Very interesting. Thanks for sharing that. Super cool. All right, we got to keep it moving here. One thing that's been coming up is, hey, measuring acceleration and some maybe even flakiness, right? You guys got that down pretty well. But one thing that's really hard to do is measuring quality. How do you measure a quality of a feature or a pull request? How do you guys do that? And what's the role of things like code reviews and code coverage, looking at issues, tickets, crashes, all this stuff? How does all that kind of play into it?
Sure. So, at LinkedIn in our engineering org, we have 3 core values. We call them leadership, execution, and craft. And this question around measuring quality and creating quality software really is a question around our core value of craft. We have all the usual suspects, right? We have code coverage and linters and formatters and type checkers and static analysis tool and security analysis tools. We talk a fair amount around tech debt, and we have things like horizontal migration efforts, horizontal initiatives where everybody will, move to the next version or uplift their code. We do track across the whole, pipeline, like what are our external issue metrics. We track things like mean time to discovery, mean time to resolution, and we can correlate some of those with, this particular change got shipped here and now it's out in the wild, and how long did it take to discover an issue in that. And, even more so, we want to track that back to a particular team that can take action on it, because mean time to resolution is one of those most important metrics for us. We also have an initiative called the Quality Strategy, and we're developing, we're thinking critically about all of these different processes and asking questions like you just said. What's the purpose of code reviews? Are we doing them well? What's the purpose of code coverage? How high does it need to be? And so we've tried to correlate between, code coverage and internal and external issues. We've tried to correlate between when you're changing product code, how often do you have to change test code? Kind of doing this like mutation testing, but observing it in the wild. And we've tried to predict even the reliability of persistent staging environments. Like if I'm going to deploy, is it useful to deploy to a staging environment? Is it useful to test against a staging environment? And what are the criteria for doing so? So it's a combination of things. Like measuring quality comes down to all these different aspects. But I am excited that we have these investments, and it really does come down to investments in build tools, right? Like you want developers to be able to measure coverage locally and run linters and formatters. And then we also have CI tools because you need to be able to run larger kind of static analysis and security analysis type tools. And then you have even larger kind of initiatives like these studies that we might invest in where we're trying to correlate code coverage and quality or test effectiveness or the reliability of staging environments.
Super cool. Thanks for sharing that. I mean, it's so complex, right? I mean, there's so much. You guys are doing so much, but that's what it takes because there's a lot of stuff going on at this scale, and you got to keep on top of it, right? To keep your developers happy. And a great segue to the next topic of, okay, you know how to measure quality. A long time ago when I was chatting with LinkedIn folks, I heard about commit to publish as far as measuring productivity, right? Really interesting, right? But how do you measure developer happiness? And that's kind of, I guess, that is for the audience, right? That's what LinkedIn's organized. It's developer productivity and happiness, right? And so how do you measure the happiness part of it?
Well, like I said, our organization is called Developer Engagement and Insights. And the insight side of it is kind of the quantitative. It's where all my expertise lies. There's also the qualitative. And it turns out, the easiest way to measure developer happiness is to ask developers, are you happy? Like, are you excited to come in? And developers, I think we've seen are pretty reflective bunch. Like they will tell you fairly quickly, I hate working with that tool, or I really don't want to make a change to this feature in our product. And you start to dig into that a little bit and you learn, it's because there's no tests around that feature, or this tool is too slow, or I wrote some automation to automate that tool because it didn't do the kind of scale things that I needed to do. So, you think a little bit about like one of the examples we use is imagine taking an Uber ride and then being asked like 3 months later, hey, how was that ride on June 5th? And that's unfortunately where a lot of, feedback and tracking the developer experience exists today, where you send maybe a quarterly survey. And we do have our surveys. We send quarterly surveys and we ask at a high level, what's your opinion of all these different tools that you're using? What's your satisfaction level? Do you have any advice for us? But we also have really invested in what we call in-band feedback, or we sometimes even refer to as real-time feedback. So imagine, you've merged a PR, and now at the end of that PR, there's a bot or an app that wakes up and says, hey, tell me, like, how was this review process? Is there anything that could have gone better here? Or you just did a merge and you passed through CI and now you're ready to deploy. And we might send an email or a Slack message, or we might ask in the product itself, how did that go? Anything you want to tell us for feedback here? Up on the slide here, you can see an example of what we call in-product feedback. Like we have a lot of different web apps and web portals. Within each one of those, there's a little widget that says, do you have feedback for us? We'd love to hear, on a scale of 1 to 5, how did that go? How well is this working? And then there's also a portal, the other side of all that. Once you collect all this qualitative feedback, developers have an expectation that you're going to act on it. They're like, hey, I told you this last week. What are you doing? And so we also have created a feedback portal where you can engage with people who give you feedback. You can thank them for feedback. You can tell them, here's my timeline, or here's my roadmap. Here's how I can address that. And you can kind of start to aggregate across feedback and say, oh, look, this is a recurring theme. We need to create a new initiative for this, or we need to invest in a product for that.
So there was a related question that I think you could hit pretty quickly to that, which was and Martin is asking, I think he mostly answered the question. He was asking about, like, how do you gather the feedback? Is it email? Is it baked into the tools? Is it widgets? Yeah. It sounds like it's all of those. His second question there was like, do you have any other approaches that boost response rate, and like which of these kind of works the best?
Yeah. We've actually invested a lot of time on trying to ask the right question at the right time. So it turns out, right, that just spamming all of engineering and saying, can you give us feedback on this? Dismal, response rates on that kind of thing. Not like web marketing bad, but like internally, it's something that we would love more feedback. And so we've actually had to really invest in being strategic about like, hey, if I've asked you a question recently, I probably shouldn't pester you again. Like let's cap it at, say, one piece of feedback per week. And it might depend too on where a tool is at in its development. If something's totally brand new and there's a pilot group of users, we might ask them more frequently, how's it going? What's your feedback? And then if it's a tool that, maybe we're deprecating soon or we're moving to a next thing, we might decide, yeah, we should ask about that once a year, or once a quarter, or just stop asking about it. So being more targeted and then figuring out like, well, what's really people's capacity for giving feedback? And how do we build a system that responds to that capacity with a global perspective, right? So we can kind of see like, hey, you sent people all these newsletters, you sent them all these surveys. Let's try and get it down to one newsletter targeted to that person, one survey or one feedback question per week or per month targeted to that person's development process.
Sure. We're getting. I want to get to these great questions that we have in there. I'm going to cut one of our questions out, but in 1 minute, what's your team's developer productivity engineering moonshot?
Yeah, our moonshot. So you think about the analytics space. I'm part of Developer Insights. There's something known as descriptive analytics, where you're kind of just like you're looking at the dashboard. There's diagnostic analytics, where you're trying to understand changes in your metrics. What contributed to this movement? What caused that? There's predictive analytics, where you start to say, where are we going to be a year from now? Or could we predict what this engineer needs to do next? Could we give them the information that they need almost before they even know they need it? And then there's prescriptive analytics, where you're making recommendations. And we've invested in all of those. I think there's maybe a fifth category that some people will call cognitive analytics. And it turns out when you collect a lot of data, you can start to build software based on that data that you couldn't build without the data. So imagine like we have these huge databases of all the code reviews that have happened at LinkedIn, millions of code review comments and issues. What if we could start to look at code reviews and we could almost automate part of the code review process? What if we could capture the expertise of a developer who's left a bunch of code reviews, and we could model that, and then on a future code review, we could put their expertise in play, provide context to that change and say, hey, here's what past people have thought about this code change, or here's something you need to consider. So it's kind of, in our mind, there's a lot of great static analysis tools out there, but we can start to build on top of that in similar ways to like if you've heard of GitHub Copilot, right? They're doing more advanced kind of code completion by looking at all the software that's on GitHub. We're starting to think about tools like that as well. How can we automate things like code reviews by using all of the data that we've already collected?
That's awesome. Very ambitious. Really cool. I mean, what else would you expect from a team that already has this complex of a productivity engineering kind of support for the developers, and all this effort to make developers happy and is going on, and which I want to do kind of this thank you to Grant slide for doing this before we go into the rest of Q&A. I mean, we could talk here for hours, and we'll probably extend the Q&A a bit. I know some folks have to get to their meetings, but LinkedIn, they're definitely hiring, and look how hard they're working to make their developers happy and getting them to do what they do best with less friction with the tool chains and whatnot. And yeah, so thanks, Grant, for doing this, and that QR code will take you to the job recs that are currently open.
I do want to say we are hiring. It's an exciting space. I mean, it's just an exciting time to be part of software development in general. But particularly, we find here at LinkedIn, like being able to reach out to GitHub and ask them, like, hey, how did you build Copilot? Like, we want to train Copilot just on LinkedIn source code. Can you help us? or being able to reach out to Microsoft Research, MSR, say, hey, you have these advanced models for doing embeddings of source code. Show us how you're doing that. Can you share the code with us? We want to train that on our code reviews or our development practices. It's really unique to be part of a company that has access to those things and can operate also at that scale.
Yeah, that's awesome.
And we have data that shows a direct correlation between companies that invest in DPE and overall employee happiness. It's a direct relationship. It's easy to capture. So it'd be a great place to work. So do we want to start going down these questions? We've got 6 open ones right now, some really good stuff. We were able to close out a couple of them because you did provide some answers actually just in the natural course of speaking. So that was great. One question that I love, how is Gradle helping the software componentization initiatives, and what parts or workflows of developer productivity do you attribute to using Gradle Enterprise?
Yeah. The Gradle specific question. So, Gradle is one of the biggest build platforms we support here at LinkedIn. We are a Gradle Enterprise customer and generally excited to adopt all the new functionality that Gradle provides. Gradle, because it's part of the build platforms, it does a lot of the heavy lifting when it comes to dependencies, downloading those dependencies, getting them integrated into a build. We have dozens of Gradle plugins implementing functionality for every custom tool you might imagine, everything from code formatters that are fairly basic to advanced static analysis tools. And then we really benefit a lot from, I would say, Gradle build scans, the amount of data that's inside there, allowing developers not only to look at their builds in a lot of detail and see, what are all the tasks, what tasks are blocking on which others, and then also being able to aggregate all of that information across the whole ecosystem so we can say, hey, maybe we need to invest more in this category of builds that are happening for this particular product development in this particular region of the world at this particular time of day. And we have had some examples where we stand up a new build cache proxy in Bangalore or in different parts of the world so that we can kind of improve those build speeds as much as possible. So I think it's been a great success here at LinkedIn. That said, we also invest in other build platforms. So don't get too comfortable, Gradle. We need you to continue giving us lots of features and we'll be excited to adopt them. So I think it's been a great platform.
Thanks. That's great. We like it too. So, can you touch on? You talked actually about a little bit of this. Can you touch on what you did with the developer productivity data? But the important part of this question that I kind of like gives you a format. What would you say are the top 3 benefits of doing all of this?
These are going to be more kind of the benefits that I'll describe will be more organizationally focused because, again, we're kind of operating at scale. We have plenty of people I won't say that. We have a lot of people working on this problem. I wouldn't say we have plenty. I think we'd love to have more. But at the end of the day, right, if you're a leader in this space and you start to wonder, how do I know that these are the right priorities? We spend a lot of time thinking about hey, should we invest in this or this? And when you have data and you can make data-informed decisions, it often makes a really compelling case. I won't say that it's the only thing that can make a compelling case, right? There's a lot of expertise. There's a lot of hard work that goes into understanding developers. And we have teams focused on, really human factors and not just user experience, but usability studies. All of that combined together, when you have a DPE org like this, I think it gives you sleep more soundly at night as a leader. Okay, I feel confident that there's data and there's expertise and there's a really well-reasoned argument around why we're doing this, and that. I think that's one of the biggest benefits in my mind. I don't know if I could get to the top 3. There's a lot of benefits to it.
I think that's covers a lot of them, right? This is an interesting question too. Seth is asking, what kind of metrics do you reflect back to developers for their direct consumption, as opposed to ones that you just collect to make management decisions?
We actually are like pretty transparent. We don't really try and hide things from developers. And for the most part, we do collect a lot of data that I think some developers would feel is a little surprising. Like we had one example where we collect build scans, so we know when you do a build. Developers feel a little uncomfortable if you start to say like, "Hey, I saw you were doing builds at 10 a.m." right? Like that, or at like 10 p.m. And so that's in general why we've developed things like a privacy policy where we say, hey, don't do that. Like developers have expectations of privacy in certain areas. But across all of our dashboards, it's all pretty much public, whether you're a VP or a frontline manager or an individual developer, you see the same interface. Like we're doing the same thing across all levels. That does also mean, though, that we've prioritized certain metrics over others. So we don't report necessarily on how many builds did you do, because we don't really think that's a valuable productivity metric. We even discourage people from looking at things like, how many code reviews did you do? Those kinds of what we call volume metrics have not been as valuable to us as an organization. We're more focused on what we'll call velocity metrics or development experience metrics. So when you create a code review, how long did you wait to get a response? That's something that refers to the velocity of the overall organization, not how many code reviews did you have. So I think by kind of investing more and focusing really on these velocity metrics, we haven't had to keep a lot of metrics secret in terms of volume overall or activity individually. And then, of course, we complement that with a privacy policy because we want to respect what developers expect in terms of privacy.
That's good, though. And yeah, I mean, having those self-service metrics, it's almost like in some ways like having a Fitbit. It's like, you have kind of the ability to kind of choose how you want to use that data. So,
and that's actually one of the metaphors for our team. Like we sometimes refer to us as a Fitbit for engineering teams.
There you go.
And the premise, right, is that a Fitbit, like I wore a Fitbit for a little, it didn't make me any thinner. But I understand the correlation between, people who measure their number of steps probably will increase their number of steps. And that would contribute to, being a healthier person. And so we're kind of in the same category where it's like, yeah, we're not here to tell you, you need to get 10,000 steps in or else. We're not trying to be like, internal affairs where we're grading people. We're just letting you know, like, well, this is what we see, and that's actually a big part of one of our products that we're creating, Insights Hub. It's really focused on, we have something in that called the Experience Index, and it's focused on your experience. And it's been great to get feedback where we're like, hey, your experience numbers, they don't look very good. Like you've got a bunch of yellow and orange in there. How are you feeling? And managers have been able to use this to identify like, oh my gosh, I had no idea that they were struggling on their builds, or let me pair this new person with this really experienced person. And then they teach them a bunch of tricks and suddenly their experience gets way better. And so those are some of the wins that we've gotten by really focusing on, experience and velocity rather than like performance. We avoid like employee performance entirely. And I would actually give that advice to other teams. If you're focused on developer productivity and you mix that with employee performance, it will create a lot of really kind of perverse incentives and confusing things for developers. And you don't want to incentivize developers to, create as many PRs as possible. That doesn't actually help with developer productivity. That doesn't help with shipping high quality products. So creating those metrics with that in mind, and then really, distancing yourself from employee performance has been key to our success.
That's, and that's something we find ourselves talking about a lot when people hear about the Gradle Enterprise solution and they hear about DPE, they're like, oh, that sounds kind of draconian. Well, what is that? And it's like, no, we have to distinguish between what we call productivity management and productivity engineering, right? Where the management side is people focused, and you don't want to make it punitive. So anyway, no, that's really good. I think we can knock out another one that's pretty tactical here and from the organizational structure. Does LinkedIn have local developer productivity teams within specific development groups? In other words, do you build your business unit first and then you have a productivity team embedded in that? Or do the productivity teams exist outside of the orgs?
Yeah, we actually have this framework called the personas framework. And the personas framework kind of looks across all of engineering and says, are there different categories of development? So, there's a category of, I'm a web backend engineer. There's a category of, I'm a web front-end engineer. There are also some categories like, I'm a machine learning engineer. And what's been fascinating for us is as we study the different workflows across these different personas, we find they're radically different. Like I said, a web front-end engineer expects a build to complete on the order of seconds, like a warm or hot build. They're clicking refresh in their browser. An ML engineer has dozens of extra steps in the development process because they're studying models, they're training models, they're preparing models for deployment, all of these things that a web backend engineer doesn't ever really do. And so what we find with each of those personas is we want a persona lead. We also want developer champions or developer productivity champions. And then sometimes those even occur within specific teams. So depending on the team size, there might be a team or an organization within a team that focuses on productivity, or they might rely more on, say, the persona developer productivity champion. And so that's also been a channel for us in terms of communication, where we're not spamming all of engineering when we come out with, a new SRE tool, but we're targeting, say, SRE engineers specifically because that's one of our personas.
Venkat is asking, you mentioned hundreds of millions of builds. I believe that's multiple products. He's asking, is it a single code repo or is it a single build? Or are you talking about multiple repos, multiple products?
We're talking about multiple repositories. We have on the order of 10,000 repositories or tens of thousands of repositories here at LinkedIn. Builds, even within a single repository now, you can have different directories and subdirectories, and each of those can have their own builds. So defining what exactly a build is, we really adopted the developer perspective. We said, well, look, every developer knows kind of intuitively, I do a build so that I can get some software artifact and I can test it, deploy it, whatever. And so we really tried to adopt that perspective. So for us, build is a fairly fine-grained definition on the slide that I shared here. There's also the build that comes out of a CI execution. That's a little bigger in terms of all the different artifacts that might come out of one execution. So I'll also caveat on this slide, some of these are snapshot metrics and some of these are per quarter. So we're not creating 10,000 repositories every quarter. We have on the order of tens of thousands of repositories. We are doing on the order of tens of millions of builds per quarter. So I think builds, CI jobs, deployments, merges, those are all a per quarter metric. First quarter.
Incredible machine. Quite a machine. And then the last one here. We have our own answers about this one too, but I'm really curious to hear your take on it. How do you measure the cost of time lost with a developer waiting on build feedback? How do you measure the cost of slow builds? Is it the obvious measure that 1 hour of build time means 1 hour of developer time lost? Or is there a better way to translate build times into business impact?
Yeah, it's certainly not that a 1 hour build time means a developer twiddled their thumb for an hour, right? And we've done certain studies and we have our own intuition around how long does a developer really wait before they context switch. And then again, it varies based on the persona. Sometimes it's seconds, sometimes it's minutes. And it'll typically vary also with a developer's expectations. So, if you're running something in CI and you say, we think the CI job will finish in 8 minutes, and 40 minutes later you haven't gotten your result, now it's time to file a support ticket or click retry because something went wrong. That's going to ding our CI reliability. So we have a variety of internal kind of, modeling and thoughts around, hey, when you have a slower build time, how much worse is that really? And we have kind of a set of thresholds that we think like, oh, you want to get this down to here, this down to here. I think it also has actually motivated us to invest in certain initiatives that create almost a step function like improvement. So one of my favorite examples is we have this framework called goals, signals, metrics. So, really quickly, generically, a goal would be we want fast build times. And one of our signals within that framework might say, well, we think that cold builds, the process, the scenario of checking some code out and doing a build, we think that should be fast. And then we might go and measure something like P90 build speed for a particular product or across all the products. And we might see it and say, wow, for this particular persona, it's not good. And then we might try and correlate that with qualitative feedback like, does that bug you guys? Is that a big pain point for you? Or have you found ways to mitigate that? And part of that actually led us to an initiative that we posted recently on the LinkedIn engineering blog called Remote Development. We're now at a point where some of those repositories, I think actually quite a few of them, can be pre-built. And they're existing on, within the cloud, within our data center. There's basically a at-the-ready development environment for you. So instead of doing a checkout and then build and then run your tests, you say, get me one of those environments. And then within a few seconds, you're provisioned with, here you go. It's already how to build. It's already checked out. It's already hot and ready. Here's how to open it in your IDE. Start developing. And so that's where you start to look at some of these metrics, right? Like, hey, if my build times go from an hour to 2 hours, is that bad? Of course that's bad. But instead of thinking, could it get worse? Think, how could we redesign it so that it's never a problem, regardless of how long it takes? Let's just get rid of cold builds in general, or let's just get rid of, code reviews that, have really low hanging fruit on them, So that's where I think some of our investments have been in terms of how do we restate developer productivity so that you have these step function improvements and you just eliminate whole classes of developer toil. That's a popular word these days.
That's a brilliant and comprehensive answer. Thank you. And thanks for the stamina and hanging out extra.
Yeah, no
I'll let Ruse kind of wrap us up here. So.
No, I mean, that was perfect ending to a great journey with you sharing all this information with us. And yeah, I appreciate it, Grant. Thanks a lot for joining, and thanks, audience, for hanging out.